Hello and welcome again to CHeM in 3. Today we look at this multiple choice question from the IB chemistry examination in May 2015. If you know how to arrive at the answer of C for this question, then perhaps you need not look any further. But if you don't know how to arrive at the answer to this question, and you feel that it's very confusing and that you need additional explanation, then what you should do is to first look at this lesson here given on this card and in the link below this video, and then return here to see if you can solve this question. And if at that point you can solve the question, then perhaps you need not go further. But if at that point you still need additional guidance, then you should watch the remainder of this video. To explain how to arrive at the answer of C, I'm going to deliberately show you how to eliminate A, B, and D, and in so doing maximize the learning. And finally, I would explain how to arrive at the answer of C. So first, let's eliminate A. And here is choice A. Copper 2 ions are better oxidizing agents than copper 1 ions. Well, to eliminate A, what you must realize is that this set of information, which is also given in the data booklet for IB chemistry, it's all showing standard reduction potentials. All of these potentials are always written with this reversible arrow, but always with something gaining electrons. In other words, something being reduced. And all of these values are always standard reduction potentials. So if you're required to compare the oxidizing power of something, then you must realize that for something to be an oxidizing agent, that thing itself must be reduced. So really, as you compare oxidizing power, then all you need to do is to see which one has the highest value for the standard reduction potential. And it is clear that Cu2 positive ions have a standard reduction potential of 0.15 and Cu positive ions 0.52. So it shows right away that A cannot be the answer. Now moving to choice B. It says copper metal is a better reducing agent than copper ions. Now we must use the reverse of the reasoning that eliminated choice A, because to measure the reducing power of something, we need to look at its standard oxidation potential. And the higher the standard oxidation potential, the stronger the reducing agent. So what we will be doing is looking at all of these half equations in the reverse direction, meaning that all of these signs would become negative as we look at everything in reverse. Copper metal is going to have a value of negative 0.52, and Cu positive is going to have a value of negative 0.15. With this higher value of negative 0.15 when compared to negative 0.52, Cu positive is actually the better reducing agent. So that also eliminates this choice of B. Now we can return to the question, because we're down to C and D. And D says copper metal can be spontaneously oxidized by Cu2 positive ions to form Cu positive ion. Now if copper metal is being spontaneously oxidized, then we need to look at its standard oxidation potential. Oxidation is loss. And we need to look at the standard reduction potential of Cu2 positive. This would have to be looked at in this direction, giving negative 0.52, and this would be positive 0.15. When you take the sum of these two, the answer comes to negative 0.37. And you should know that a negative value indicates a non-spontaneous process. So it means that D is eliminated because the process is not spontaneous. A positive answer is required for the process to be spontaneous. And finally, we return now to the reason for C being the correct answer. And before we verify C as the answer, it's useful to go back and to think about the zinc copper cell. In the zinc copper cell, the standard electrode potential of zinc is given in the data booklet as negative 0.76, but it is the thing that is actually being oxidized. Oxidation is loss. It loses electrons, and it is the reducing agent. So its oxidation potential is found by reversing the negative 0.76 reduction potential. And copper is the thing that is being reduced. Reduction is gain, and Cu2 positive gains 2 electrons to form Cu. So its reduction potential of 0.34 is used, and then you just take the sum of these two values, oxidation and reduction, and it's a positive value, so you have a spontaneous process in the zinc copper cell. Now, in this case, if you had Cu positive going this way to become Cu2 positive, in other words, you are looking at its oxidation potential, and if you had Cu positive gaining an electron to form Cu, which is its reduction potential, and these two, just like the zinc copper cell, were put together, then taking the sum of negative 0.15, which is the reverse here, or the standard oxidation potential, and here the standard reduction potential, taking this sum would give you a positive value of 0.37, and that would indicate that you have a spontaneous process.